This tutorial will cover laterally loaded pile analysis. This module can be used for both drilled or driven pile and caisson. On the opening screen, click Plant Mode and then Create Drilled or Driven Foundation. A wizard will pop up with a sequence of steps to create the foundation design. The user can skip to any step using the navigator on the left or go in order. The first window, called Drilled Pier or Driven Pier Job, allows input for general project information, drilled pier specifications, and loading type. The only input in project info that is required is the pile or pier ID. This is used for differentiation among various laterally loaded pile analysis jobs in the same file. In specifications, either drilled shaft or driven pile can be selected. Then, unit system and design code must be chosen. Also, the user can choose between static and cyclic loading types. Loading type selection is important because depending on the loading type, different equations will be used to generate nonlinear soil springs or PY curves. The next section defines the pile cross-section. It is important to define cross-section properly. Lateral pile analysis is heavily dependent on the non-linear bending stiffness of the pile cross-section. There are two main types of shapes, rectangular and circular. For both section types, reinforcements must be defined and bars will be distributed symmetrically. The user can additionally define outer casings and inner core. The program will automatically calculate nonlinear bending stiffness to be used in analysis. After analysis, the user can view the bending stiffness graph at the graph page. Note that one pile can have multiple section types along the length of the pile. For simplicity, we will use a circular section without casing. I'll change bar counts to 16 and extend the pile to 30 feet. Pier height above ground and water level must be specified as well. In the soil section page, the user can define multiple soil strata along the length of the pile. Depending on soil definition, nonlinear soil spring or PY curves will be generated to be used by the analysis engine. As you can see, there are 14 types of soil to choose from. For the tutorial, I will input 2 soil strata. The first layer will be clay and the bottom layer will be sand. The first layer is already created by default, but the user can obviously change default type and values. I'll change the layer depth to 10 feet, click on Add Layer Below, which creates another soil stratum, change the layer depth to 30 feet, and change the soil type to Sand API. So, soil layers are defined as the combination of clay and sand. We are using other parameters as default. The soil diagram is to scale and shows how each soil layer is actually defined by the program. The load page has different options. This is where we can define pile head conditions. At the top of the pile head, we can either apply a shear force or induce a known deflection value. Similarly, a moment or a rotation value can be applied. I will use program default values and apply a 100 kip axial load. Please note the diagram for load directions. Many analysis and design criteria can be defined here. If it is a battered pile, we can input pile battered angle here. If the ground is sloped, slope angle can be defined here as well. By default, the program will divide the pile in 25 segments. The other design parameters are related to axial capacity calculations. Axial capacity is calculated based on the method defined in API RP2A WSD 2005. I will use all of the default parameters for this exercise. Reinforcement and concrete design parameters will be primarily used for the column design. After all of the steps have been completed, click Finish. This example says Edit because I switched to an existing example file to show standard values. The pile geometric model can now be viewed in the geometry view. Please note how pile and soil inputs are shown graphically. It's important to take a look at this view to make sure enough soil stratums are defined to cover the whole pile length. From this point, you can either edit, which takes you back to the drilled Pier creation wizard to edit any section, or you can delete or design. You can also input any number of pile lateral analysis jobs in the same file. Designing creates a calculation sheet and graph page. The first part of the calculation sheet shows output related to lateral analysis. All the generated PY curves are shown in numerical tables. The user can choose how many tables are shown by checking or unchecking the boxes in the calculation sheet customization dialog. The second part of the calculation sheet deals with axial capacity calculations, which include both tip resistance and skin friction. The last section is the graph page. All the graphs related to axial capacity and lateral analysis are represented here. The moment stiffness graph shows cracked and uncracked behavior of the defined concrete section. All of the PY curves are shown in this graph. As you can see, the clay PY curves are easily distinguishable. If there are multiple cross sections, moment stiffness and moment curvature curves can be viewed for each section separately. Thank you for watching this tutorial.